In this video, we talk about 4.45 on page 140. So this is exercise in the book. First, we look at the probability. So we have two events. Well, a lot of times when you do those questions, even if you don't know what each event represents, you can still do the problem. But if so, this gives you a real life example. So A means 5 or more alcoholic drinks in 1 year last year. B means female. So you can see B, P of B means 50% female, and A and B means and not only so the 14% of female had 5 or more alcoholic drinks in 1 day last year. So that's the sort of like the probability. So we are given those probabilities. Let's draw a Venn diagram to help us solve the problem. You can use formulas to do the problems, but it's easier to use the Venn diagram. So first, I can draw two circles to represent each event, and now I know that P of B equals 0.5. P of AB is the intersection, so I'm gonna put 0.14 in the middle. In the middle, that's right here. It's 0.14. And the left side circle, I'm gonna name it A. The right side circle, name it B. And we know P of B is 0.5. Pay attention to the notation. P of B is 0.5. So it represents the entire circle. The probability of the entire event B, entire circle, is 0.5. And if I want to mark the right section of B, that would be 0.5 minus 0.14. So I will get 0.36 on the right side. And now I don't know the left side of A yet. And next we look at this another condition right here, which says P of A B bar. That means the probability of the section which falls in A but falls out of B. So inside A, outside B. So let's look at the picture here. Inside A, outside B. So you gotta cut the B part away. So this is the left section in A, so which is 0.23. So I'm gonna put down here 0.23. So we have the probability for these three little sections. Now we're gonna use those numbers to do the questions. So first here, AB, which is given, AB bar is 0.23, and then we look for A bar B. A bar B means the section outside B, A, and inside B. Outside A, inside B. So look at the picture here. Outside A, inside B. So that would be, if it's inside B, and that would be this. I should use a different color. Okay. So that would be this, the right section of B. So that's 0.36. So we can put in a table here, 0.36. And A bar B bar. A bar B bar means outside of A and outside B. Notice that we always have what we call a universal set, a universal event. So that would be the total. Okay, let me draw this. Would be we always draw a rectangle or square to represent. Wait. Oops. So the rectangle represents the sample space, which means everything, all the possibilities. So the probability of all the possibilities is always equal to 1. So let's determine the section, the area that falls outside both A and B. So clearly, I'm going to use blue color. That would be outside. Of course, it should be inside the box. Inside the box, but outside of both A and B. So it's going to be all those sections outside of both A and B. It shouldn't go out of the box. Okay, so that is going to be A bar, B bar. And so how do we find the probability of A bar, B bar? So that's the section not only outside of A but also outside of B. So well, if we know the probability of entire box is 1, so if we take the 2 circles away from 1, the probability of these 2 events away from 1, and then we get the outside. So first, let's find out the probability of these 2 circles, which actually is A or B. So we add all these 3 numbers, 0.23 plus 0.14 plus 0.36. So we add all these together. So we get 0.23 plus 0.14 plus 0.36. So that's the probability of A or B, the inside of 2 circles. So that would give us 0.73. And if we want to find the outside of A and B, that would be the big box minus 0.73. That gives us 0.27. So that's the probability for A bar, B bar. Now let's go back here. So we can fill out the table. And what is the probability that A does not occur and B does occur? So A does not occur. We write down the symbol A for A. A does not occur, so it's A bar. Yes. So we have A bar, and B does occur. So and we don't have a symbol for that. We just write on B. So A bar B. Now we look for the section which falls outside A and inside B. So apparently from the picture, it's the red section right here. So we know it's 0.36. And the second question, see, find the probability that either A or B occurs. So it's A or B. And look at the picture, A or B, that would be the 2 circles. So when we look for A or B, it's like either in A or in B. So if I use color yellow, either in A, so first I'm going to shade A, or in B, I'm going to shade B. So we shade both of them, so either or. So you can see that's these 2 circles. And again, the middle part is shaded twice, but when you do union, you don't use it twice. Don't repeat it. Okay, so the probability, we add all these 3 numbers, which is 0.73. We already did it. Now, the next question, find the probability that one of these events occurs and the other does not. So we have either A B bar or A bar B. So we did A bar B, we do A B bar next. So the A bar B is, we found the probability for A bar B is inside B, outside A, so it's 0.36. And now we do probability of AB bar. A inside A, but outside B. So inside A, outside B, look at the picture, that would be the left section of A. So that's 0.23. And because it's either or, so the answer will be, if I put it up here, so it's P A bar B or AB bar. So that would be this section here and the red section here, and you can see these two are independent. So we add these two numbers, equals 0.36 plus 0.23, and the answer is 0.659. Okay, so that's the answer for this exercise.